který se bude zamýšlet se svými spoluautory nad hodnocením nebo nad automatickou metrikou, která hodnotí strojový překlad. I suppose that the talk will be in English because it has an English title. So once more, I would like to welcome all those present at this talk. And I also want to welcome the speaker. And if everything is okay, no, not yet. Okay.
Have anything to project? Maybe this will work. Yeah, we have some different.
Tell us about your work at Microsoft.
Oh yeah, so yeah, thank you. I think would you mind if I will take it down?
Yes, please take it off.
I think I.
Yes.
So hello everyone, I'm Kocmi and I'm happy to be here back at So I'm currently at Microsoft in Munich, working under Pretrained Metrics in Microsoft Translator team, where our main focus of our team is the evaluation of machine translation. So we are doing several steps. So first step is of course automatic evaluation, where when we are deploying new models, we usually first evaluate it automatically against some human references. I will briefly talk about it a little bit later. Then also we so actually the first step is that we employ human translators to translate text for us, which we then use to automatically evaluate our machine translations. Then the second part our team is working on is the human evaluation of the machine translation, where basically we translate a lot of sentences, usually 500 sentences by all the, usually the production machine and the new candidate machine, and then send them to humans to evaluate them and tell us, oh, this one is better or worse. And the third part is actually the investigation. What are the best, I don't know, recommendation or ways how to evaluate machine translation, and that's what I will be talking mostly in this talk. So yeah, my team is located in Redmond, Seattle, but here in Munich we are me and Christian Petterman, a little bit remotely from others, and it's nice. I'm actually super excited about this work because I got my hands on the corpus of 4,000 over 4,000 systems that have been evaluated by humans. I will show also later in the talk that it's way bigger than what is usually at WMD every year. And that was so fascinating to work with that huge corpus and to make some evaluation of those. So basically, there's few new caveats how to evaluate automatic metrics in my talk, but it's the more corroboration of the results that have been in the community since 2015. So I will not be showing you. I can maybe already spoil the results. So like I will not be showing that. I'm not the first one saying like BLEU is the not good metric. There is like people saying that since 2006, and the metrics in WMT metrics share tasks, which every year evaluates these automatic metrics, as well show that BLEU is not really good metric at all. So this is just like on the huge corpora of the system evaluated by humans. And I ask if is everything set up? Yes, you can. I don't have this part. Yeah, I can do it. So, yeah. Okay, so I will. No, so this maybe this presentation will not be happening at all. Yes, so. I'm also not sure if people on who are online, if they hear me and if everything is fine. So hopefully someone, if there is problem, write it to chat. And Okay. I hope it's a little bit better. And maybe we see the screen. Yeah, but yeah, I can. No, we are. No, it's over there. Wait, no. Maybe we can just duplicate it. Will it be this? I think this is the like this works. I just duplicate the screen. Okay, so hopefully now it will work. Yeah, so I'm Tom Kocmi, and this is the rest of the people with whom I've collaborated on this paper. And the paper is named "To Ship or Not to Ship: An Extensive Evaluation of Automatic Metrics for Machine Translation." So the outline of the talk will be, the first I will do some brief introduction to how the machine translation is evaluated and how humans are used to evaluate the machine translation. Then look how to calculate correlations between humans and automatic metrics. Then I will show the results, mainly which metrics is the best suited for the automatic machine translation. Then I will talk about the statistical significant testing. Last small point is about like if we are overfitting on the BLEU, and at the end there is the recommendation how to automatically evaluate machine translation. Before I start the talk, of course, human evaluation is always the gold standard. So if you cannot do human evaluation, then these are the recommendation. But anytime human evaluation is always better. Metrics so far are not superior to automatic metrics. So let me start with the motivation. So this is from the paper by Benjamin Murray et al., where they show that when they evaluated ACL, STAR, and EMNLP papers, they show that basically all of the papers use BLEU as the main metric. And what is concerning is that less than 10% of the white columns, less than 10% of the papers use human evaluation. So a lot of papers claim the improvements by only looking at the automatic metrics. Oh, it works, perfect. Thank you. So no, it does not work. I will just use the keyboard. Yeah. So the second part is that also, a lot of papers rely on BLEU only. This means that they do not calculate any others. So they don't calculate human evaluation. They don't calculate other scores. So they just use BLEU metric. So this is quite overfitting. That's like the whole community is using single metric, which is not perfect. So we will be dropping systems or models that are better, but just it's not visible on the BLEU. And also, we don't use the BLEU as it should be used. We use with a single reference. It should be used with multiple references. So that there is more caveats to that. And it's concerning because even at WMT 2015, the BLEU is not the best performing metric. And since 2015, there is a group of pre-trained metrics, which I will talk a little bit later, which are way better than BLEU. So, and yes, and last part of the motivation is that less and less papers do run statistical significant testing. So often what's happening is that paper claim improvements on solely, oh, we have 0.2 BLEU improvements, 0.5 BLEU improvements, but actually it can be just a random noise for the selection of the random seed, for example. It does not necessarily have to be the improvements. And statistical significant testing on automatic metrics are not the perfect solution, but it still can filter out some of the random improvements that could be like could do result in the work. So let's start with the automatic evaluation of machine translation. So I will briefly describe, just so everyone would be on the same page, how we evaluate machine translation. So we usually have a source. We have it reference translated by humans. And then we have the system output, which is generated by machine machine model. The most common way how to evaluate metrics is to use the BLEU, but there is a group of the metrics that we call StringBase, which basically do some kind of string evaluation between the reference and the output. So the BLEU will, for example, calculate n-grams match between the reference and the system output. This is a little bit problematic since usually for one source, there is multiple various translations, and when using single reference, it can miss a meaning in different paraphrases of the same translation. So the second group of the metrics is called Pretrained Metrics. They started to be popular in, like a few years ago, and mainly in last 2 years. And they use some pre-trained model, usually language model, like the huge language models like BERT, XLM, and various others, to first embed the metric, embed the sentences in some multidimensional space and then calculate the differences there. So the improvements, the benefit of the pre-trained metrics are that they can evaluate even paraphrases. They are not that strictly, they do not do string evaluation. They evaluate it on the embedding, and if the embedding can evaluate the paraphrases, then it can evaluate it as well. So this is the main difference between these two metrics. And the last point is, there is, since last year, there is a group of pre-trained source-based metrics. So those are metrics that do not need human reference. They just take the source and and the output of the system. These are very interesting to see because basically they are opening the world of monolingual evaluation, where you don't need to pay humans to translate the reference. And if they would reach a high performance accuracy, they would actually be like useful, because then you can evaluate across various domains in various genres of the text. And because usually we are evaluating on the news text, because that's the most common type of the domain used. But now with the monolingual evaluation, we could be evaluating on like basically taking any monolingual text, translating them, and just evaluating. So this is, they are also pre-trained, but I'm putting them slightly different, separately, because they are quite interesting. So the main differences are the string-based work for any language. As long as you have the references, they will work for that language. Pre-trained work only for the languages that they've been trained on. For the string-based, they are trackable. You can always find which n-grams made the decision of the metric. Pre-trained are still a little bit black box. There could be problems that they will be biased from the training data. There will be problems that we just did not discover yet. The string-based, on the other hand, need high quality references, and often BLEU would be beneficial if there would be multiple references. And they have problems with morphological forms, and especially morphologically rich languages, where the paraphrases do really change the sentences quite a lot. On the other hand, the pre-trained can to some extent evaluate paraphrases. And lastly, this is what's been shown in WMT metrics share task, and I will confirm it in this work, is that the string-based we already know that they have lower correlation with humans than the pre-trained metrics. So how to evaluate metrics against the human judgment? So I will get to that a little bit later. So first, when we are evaluating the machine translated output, we do not use the references, not to bias humans to try to compare the output with the reference, because that would give it a bias. So we are using source-based direct assessments, where the evaluator is basically asked to read the sentence in the source and in the output translation, and then score it somewhere between like 0 to 100. They don't see the scores, they see just like not good, perfectly translated. And then, so how to evaluate it? So in our work, we are using the system-level evaluation. Often in the metric share task, they evaluate correlation on the single sentence level. So how well does metric correlate with the humans on a sentence level? We are more interested on, because that's not really natural way how the metrics are used. The metrics are used, we have the baseline system, we have the better system.
which is better. And then we evaluate the whole test set. So we are more interested in the system level, which is what's the correlation between the score for the whole test set between the metrics and the humans correlation. So that's the first caveat, first difference. And the second is that we do it in pairwise evaluation. And that's the biggest difference. Is because in the past work, they usually evaluated on the absolute score. So absolute scores for the human judgment against the metrics on a single sentence. But we rarely need correlation. We don't even need if the metric will linearly correlate with the humans. We just need if they will give us always the same decision if system A is better than system B. And this is what we mean by the pairwise. So we all in our analysis, we always talk about the system pairs and asking if the humans gave the system pair same different ranking decision if like system A is better than system B or vice versa. So the base unit we are using is the difference, which is simply just the difference between the score. It can be metrics or human score for the system A minus the system B. So now let's see how they would correlate, just like before, how we will be using them. So let's plot everything to the graph. And then here you can see on the x-axis, there is the difference in the automatic metrics. And on the y-axis is the difference in the human scoring. Every point here is the one single system pair. So let's say that this red dot would be point to would have a positive difference for the BLEU, but negative for the humans. And here what you can see is majority of the points are somehow correlating with humans. The main, as long as the points are in the white rectangles, it's good because they are showing the same different direction. They will tell us that system A is better than system B in the same way as the metric would. The problem comes with the red field. So whenever there are dots in the red field, that means that the metric and humans did not agree. One of them said system A is better and the second said system B. So how can we evaluate this scenario? How can we find out how well the metrics will evaluate? So first intuition could be like use Pearson correlation, but no, first idea could be Pearson correlation, but actually we want to show that that's not possible because in this scenario, we don't ask the metrics to be linearly correlating with humans. We don't even ask them to have some same ranking for each of the language pairs. And it's nicely see here for Prism and especially for BLEU. When you look for the green points are into English and the green points, blue points are from English, green points are into English. And you can see that it used different scale for different direction. So that's why we cannot use Pearson's correlation, for example. So to solve this problem, we came up with a simple solution and let's use accuracy. Let's just calculate how many systems did get into the white triangles divided by the total number of systems. And here on the right picture, you can see, for example, for BLEU, all the systems that did not agree between the humans and the automatic metrics with the BLEU. Okay, so that's the accuracy. And one problem with the accuracy is that we do not take into account much the system that do perform the same, like roughly the same. So let's say like if the human difference will be like around 0, it's kind of like possible that these systems are actually performing the same and there is not significant difference between the systems. So to solve this problem with the accuracy, we calculate Wilcoxon rank sum test and use the value on the human judgment to remove the systems that are based on the human evaluation. We always in this work use the humans as a gold standard. So we filter out all the systems where humans thought that they are kind of same. And depending on, so if we would use like all systems, then the accuracy for the metering would be 47. And then we are removing the systems that are more and more similar. You can see it in the graph that basically the systems around the 0 use mostly are disappearing. It's based on the statistical test. And of course, as you can notice is that when you remove the most similar system, the accuracy will grow. However, it will never get like 100%. There are like systems which are like quite obviously are incorrectly evaluated by the metrics. So this is what we are focusing on to evaluate the metrics. And we are using internal collection of data. In total, we are using 4,380 systems evaluated by humans. Just to put it in contrast, last year at WMT, there was 184 systems. So even taking into account all the WMT that have been run, this is way bigger collection. It's 2.3 million annotations. We cover 101 languages, although some of the metrics do not evaluate all the metrics, all the languages. So we always use the biggest set of languages that all metrics are evaluating on. And the main difference is that we use qualified bilingual annotators, which we evaluate their performance and we pay them a lot, and also we remove them anytime they're not passing the quality control system. So in contrast, at WMT, there is various groups of the annotators. So what I wanted to point here is that the set should have a similar, should have similar distribution and every in various access. I'm just missing the word. Sorry. Yeah. So it does. And also we will publish the data. This is one point where it's not published because it's for 4 months. It's blocked a little bit by the legal team. So now we are waiting for the approval, which we should get. It just takes a bit time. And this is the list of all the covered language pairs. Mainly, what I just want to show here is that it's not balanced. So the English, French contain 145 systems, but there are like even like Vietnamese, Welsh, I don't know, Kiswahili, and there is a lot of language pairs that have less than 15 systems. So now let's go to the results. Here in this table, this is the results for all the systems. What you can see is the background always show like roughly the scale just to better visualize it. And the big numbers show the cluster of winning metrics. So we calculate with alpha level 0.05, the cluster, basically taking the winning metric and calculating the cluster of all the metrics that could, by random chance, if different set of systems would be picked in the set, would fall into the winning cluster. So although there could be like one winner, we rather take the full cluster as a winning cluster. So this is, and the second point, these various columns are, as I showed earlier, when we've been removing the most similar systems. So what you can see is that the accuracy grows. Yeah, the accuracy is not comparable across the columns. It's like you can compare it within each column. And the last column shows specifically systems that are most intriguing for evaluation. So basically we remove the systems that are most similar, but also too trivial to recognize. So we are focusing on the systems that should be well evaluated by automatic metrics if they do differ or not. So that. And let's look at the main results. So from this table, first thing you can see is that the Comet is the best performing metric from all of them. And also it's nicely seen that the pre-trained metrics make a nice cluster of way better performance than the string-based metrics. So that's one result. Only difference is Prism source, which is the source-based metric, which actually do not have a great performance. Regarding the referenceless metrics, there is Comet source. That's the metric Comet source and Prism source. These two metrics do not use references for evaluating of the machine translation. So these two metrics are actually, well, the Prism that did not work well, but Comet is quite interesting because it's a really well-performing metric across all. So it could actually open the world of monolingual evaluation. And it's interesting to see. Also, what I wanted to show is that character F and actually other pretrains perform better than the BLEU. So, but the differences are not that huge differences in the accuracy, as it would be like, for example, comparing the Stringbase with the pretrained metrics. So, okay, so maybe the results are actually just because of the way of which set of systems we have in the set. Maybe because half of the systems are translating into English and roughly half of them out of the English, or it's not exactly half. Maybe it's because they just are good with the English. And also majority of our test set are like news-like domain. So let's evaluate various scenario if we can see some problems, because maybe just due to the set of systems we have. So first, let's evaluate into and from the English, if there is a difference in the behavior between these two directions. And in general, the ranking of the metrics stays roughly similar. It's still the comet is the winning metrics. There is nice cluster between the pre-trained and the string-based metrics. The only difference is mainly for the BLERT, where there is kind of like drop in the ranking of the BLERT, which could be because this is the only metrics that was trained only on English text. So it's pre-trained metric, but never saw other languages than English. So it's surprising that even pre-trained metrics that haven't seen other languages could evaluate other languages. So that's like one of the interesting. And when just using the systems into and out of the English, it doesn't make much of a difference. So it's just to give a bit background to that. We think it's mainly because it learns how to what are the important features of text and how to map the engrams. It could simulate the string-based evaluation. So it sees the reference, so it can do some kind of comparison between the translation and reference. So maybe the results is because we use mainly Latin scripts. So let's see how it behaves for the non-Latin or especially Chinese, Japanese, and Korean logogram languages. Unfortunately, for these two groups, we don't have many language pair systems to evaluate. So it creates a huge group of the systems that fall into the winning cluster with the Comet, which got still the best, the highest score. However, the main result is we don't see any problematic drop, especially for the Comet. It's still like the winning metric, even for the Chinese, even for the non-Latin. So we still didn't see anything problematic. And that's a good point, because basically we are evaluating if they have some possible problems. So maybe the main improvements is that Comet and and also BLERT are fine-tuned on human judgment. So they took the human judgment from WMT metric share task and fine-tuned the final scoring with the human judgment. So maybe they just learn how to simulate the humans for the new task. So what we will do is to evaluate only the languages that never been part of WMT. So the metrics couldn't be fine-tuned on those languages. And also speech domain, which is not the news domain used in WMT. And here, I think it's the most important result is that there is no drop for the Comet in this evaluation at all. So as for the speech domain, it's still the best performing method, and also for non-WMT languages. So this concludes that the metric do not seem to be overfitted on the news domain or on the WMT languages. It doesn't completely say that there are no problems. There could be still some biases or some other problems we just did not discover. So we just try to various scenario to see if we can discover something. And also to conclude, to conclude these results is we did the meta-analysis of various papers. So these are the various WMT metric share task. You can see the number of systems used in each evaluation, and we calculated just based from their work, we evaluated the scores. And what you can see is already since 2015, for example, the character F do have better score than BLEU. Also, maybe I have better picture. I do have better picture. Also, second point is that Pretrained metrics, since already they've been first introduced in 2015, do outperform BLEU and especially the string-based metrics. And so the WMT metric share task, basically since 2015, we do have these results that there are better metrics which should be used. I just want to point here, there is interesting what you can see. There's character F, and Comet has worse performance in this one column, and that's there was one broken system output where humans did not care about the output. Like basically they tokenized every character in Chinese. The system tokenized separately and put spaces around, and that actually ruined the character F. We don't know why the Comet was broken, because when we discussed this with the authors of Comet and the metrics share task, and we also tried to rerun it, we didn't get the performance. So that's basically, this column is without the one system, and it confirms the same results. And as next to the WMT, there was also a paper by Freitag et al., which they used MQM, human evaluation, where the humans are not asked for just scoring. They are really asked, oh, is it fluent? Are there grammatical errors? And they need to point out exact errors in the evaluation. So it's more robust evaluation. And in the evaluation, they also confirmed that the Comet was the best performing metric. Character F was for them the second best. And here is the Chinese, the same problem as I mentioned before, but still the Comet in their evaluation was the best performing. So last, I'm slowly getting to the end of the presentation, is the statistical significant testing. As earlier, I showed the slide from Benjamin Murray. In recent years, there is a drop in usage of statistical significance testing, and a lot of papers use automatic metrics without statistical testing and human evaluation. So let's just try to how it would what we can evaluate with the data. So there are various statistical significance tests. The paired bootstrap resampling is probably the most popular. But also we wanted to show that, point out that paired student t-tests could be used for these paired decisions for the Comet, basically for all sentence score averaging metrics. So we took the paired bootstrap resampling, and here the first column basically shows what would be the accuracy if we would always trust the metric. Let's say metrics will tell us like, oh, it's a 0.02 BLEU points improvement, and we will trust it. Any difference? So then on the set of our system, we would get accuracies for, like, the Comet would be 83. Those are the same numbers you saw earlier on the one of the first slides. So 83.4 accuracy for Comet. Prism source would be 73.4. Just to point out, 50% is random chance. Just maybe that should be on the slide. And this is these are the accuracies if we would filter out all the systems pairs where the statistical significant test with alpha 0.05 would not show significant difference. So that still does not say that they are not significantly they still could be, but just the test did not discover this difference. And basically, all the systems that can, when you evaluate the system with Comet and also pass the statistical significant test, you get to 95.1% accuracy, which is quite high when you don't have a budget for human evaluation. So this just shows that by using pre-trained methods as well with statistical testing, you can reach quite like robust results even when you do not have the budget for the human evaluation. Although human evaluation still should be the standard, and humans can discover problems that these metrics will not discover. However, also one point that we would like to point out with the usage of the statistical significant testing is that sometimes the metric can kind of like incorrectly reject a better system. So out of the systems that did it reject it, and if we would say that the humans are always gold standard, because also humans can make errors, of course, basically like roughly 17% of the system would be incorrectly rejected. So if someone, so this result could be used that whenever the statistical significant test would reject the model, there is still like chance to like just running it with the human evaluation to get the gold standard. And this is the last part of the talk before I conclude. So we show that BLEU has accuracy 74.6. So is it possible that it misled us to ignore some of the better models? So we are using it for 20 years. You saw the slide that everyone used BLEU. A lot of papers trust BLEU only for without humans and without significant testing. So what we did is the last experiment is to compare two sets of systems, and all of them were always compared in the same campaign. So the same humans evaluated all three systems. So we try. So the conditions should be as close together. So we took a set of two systems, which was our past system and our improved system. We do think that these are incremental. So there was new data, slight change in the architecture, some tweaks. So they should somehow be like related to each other. And since internally we use BLEU as a step before running human evaluation, they have been evaluated in the time with BLEU. So the researcher who came up with the improved model had to check it with the past model and see, oh yeah, I have better BLEU. Now I'll send it to human's judgment. And the second set of system is the evaluation between our model and some other public empty model. So these two models never had they don't have same data, same architecture. They are unrelated. There was never in the lifespan of those models someone who would check BLEU and see if there is some improvements. So we will publish these models. And here let's evaluate these models. And what you can see here is that for our incremental models, the BLEU is the best performing metric. So so in the step, although this is, I will summarize and then I will say like more about that. So the BLEU is the best performing metric on those. That could be resulted because there was at some point researcher discarding models that would be rejected. That would be rejected by BLEU. And if we look at the independence, we actually get the same data table that we saw earlier. So the Comet and the Pretrained have like the best performance, and then there is the slight drop towards the BLEU or the string-based metrics. So what shows this table is that we possibly do overfit on BLEU, and we use it too much to filter out models that could be better. But it's indirect evidence because we would have to evaluate these systems that we dropped if there is the result. So I think this is the weakest point of this paper because it just like shows something that we could not evaluate, that there is this possible problem. What I just wanted to illustrate is that maybe because everyone uses the BLEU, we use it for 20 years. Since 2006, there are papers showing that it's quite problem that we are using BLEU so much and it's not best metric, etc. Maybe it's time to actually stop using BLEU, and I would like to end before conclusion end the talk with a quote by Marilyn Sterson that when the measure becomes a target, it ceases to be a good measure. And we're using it 20 years. Everyone uses it. We don't recently run human evaluation. The statistical testing is not used. So the BLEU do affect the machine translation field a lot. And maybe now with the better metrics that are way better, it's time so we would shift a little bit, maybe diverse the metrics or shift to the new better metrics. And that's where I would like to conclude with the recommendation how we think the machine translation should be evaluated. Sorry, I need to drink a little bit. So the first recommendation is use Comet as the primary metric. We showed that it's best performing, and as far as we know, and also others showed, Comet seems to be the best performing metric at this point. There will be better metrics in the future. Maybe we will discover problems with the Comet. But also we recommend using character F as a secondary metrics because it's string-based and maybe there are some biases that the Comet has. And if you will see some huge discrepancies between the character F and the Comet, then it should be more investigated if there is any problem with this pair. We've been also thinking about trying to support that what would be interesting to see if every research lab would pick one of the metrics and diversify it. But the main reason why we stick to recommendation to Comet is that we fear that there would be some kind of like metric hacking. Basically, people could pick a metric that suits the results. So that's why we are recommending the Comet, because now it's the best metric at this point. Second is, please run the statistical significant testing. It's not the perfect solution, but it's the best with automatic metrics you can do at this point to get confirmed that the improvements are actually statistically significant. Although sometimes it will reject even models that are improvement, but just not seen by the metric. And the third is, please publish output of your systems. So the common problem also shown by Benjamin Murray is that a growing number of papers just copy the scores from the other papers and do not recalculate. Some of them at least calculated with the SystemLevel, which should be comparable. But there is a growing number, up to like 30% of the papers who just like copy the number, and the BLEU are not comparable. So we think the most important point is to always publish the outputs of the systems, because no one actually can, rarely it's easy to replicate the work. And if you output the public the system output, someone with in the future there will be new metrics coming and some new models. So then people can just take your outputs and evaluate with better metrics, with human judgment if they have budget, and etc. So this is the end of the talk, and thank you for your attention and for the presentation. And let me know if you have any questions.
Thank you very much for your interesting talk. I think today the linguists will not speak too much, so I will just give the floor to people who are in the business. I'm not pointing out to anybody, but just and so who will start the discussion? Andro.
So thanks very much. I'm very sorry that I missed most of the talk. Also, I didn't realize that it was broadcasted, so I heard some of it even before coming to the room. Well, Dominic was watching it in our room, so that's great. Yeah, how much confidence do you have that people will move to using Comet and CHRF in their papers? So what kind of impact do you really expect there? And SystemLevel, when will that include Comet? So.
Yep. Yeah, those are excellent questions. So yeah, I'm not the first one. We are not the first one who are trying to kill the BLEU. And there was papers before showing it. 2006 was the first paper actually saying that the MT community in 2006 are already overfitting on the BLEU. So as for our confidence to actually help to traverse to other metrics, I think now the story is a little bit different, because there are the pre-trained metrics that haven't been in the past, and we could show, and also the BMT metrics share tasks show that the pre-trained metrics are way better. So what I think we will see in the future is that papers will start having multiple metrics, and probably the BLEU will stay there as one of the metrics. What would be nice to see, to have like not making the decision based on the BLEU, because also one of the comments we got from the reviewers is that, yeah, what about the reviewer number 2? He will ask for the BLEU. So yes, as long as majority of the field will be publishing BLEU numbers, they will. It's probably incorrect not to publish it. Maybe just put it in appendix would be nice. So I think stuff will change. Also, with this year, the Benjamin Murray made a huge paper that I cited across the work, which I think will make a huge impact on this shift. So I'm not confident that a huge change will happen, but definitely some change will happen, because already some shared task at WMT this year decided to use BERT score, for example, as the main metric instead of BLEU, and that. As for the StringBase, we talked with Matt, and he don't plan to support Comet with the StringBase. What was the question about the?
Yeah, so actually people have kind of adopted StringBase. We saw that in the last chart by Marie, which is good. The problem is that StringBase does not use CHRF by default. If that would be the main output, then maybe that would already put the secondary recommendation of yours to every paper. That would be good on its own. But the Comet as the first recommendation is not there. And if I understood correctly, MatPost is not planning to support it. Yes.
But one point is that we are like internally in Microsoft, we are using Comet as the main metric since April when I finished this internally this review. We use Comet as the main metric, character F as a secondary metric, and BLEU for reasons because everyone knows. That's actually another part. Like researchers think they know what BLEU mean, but actually when you ask, they don't know, because yeah, they know how other systems been evaluating on the same set, same test set in the past. But even for the same language pair, you can get quite various scores for different tests. So I think the intuition to know how BLEU should behave is not that solid, but people think they believe. So that's the reason why we are still reporting BLEU, although we try not to pay attention. So the main shift, I think that at some point, Matt will also like change the ordering, and the character F will be the main metric in the StringBase.
So that's the thing that you should push Matt to do, to really swap the order of the default outputs or the default signatures, yeah. So otherwise, let's hope. There has been a project also run by this department, QT21, where I think every European lab doing machine translation, every important European lab doing machine translation was involved in. And there we even kind of agreed that we would try to stop reporting BLEU or actually report many other metrics. Still, that didn't succeed. So maybe the Mary paper, did she analyze, or did they analyze the country of origin of the papers? So I think that there is also a lot of researchers who came to the field fresh from other areas, and they do not have the experience of a decade of failed BLEU or yeah. So maybe we need to educate the newcomers. It's not
it's not in. I don't have it the slide, but what was nice? Maybe it could be. Yeah, it's yes here. When we've been discussing this with Christian, we have the intuition, we have the reasoning that usually like people coming to studying the PhD around like the 2017, 16, 17. Came already starting to work on neural models. Yeah. And those, so they see only other neural models. Usually fresh candidates started that. So if no one tried to push them for here I have just the slide with statistical testing. They did not know that they need to report the statistical significant testing. That's why you can see a huge drop in the reporting of statistical testing. So this could work if like majority of the laboratories around the world and researchers, especially senior researchers, could give these recommendations or various recommendations to pass on, because otherwise, if there will be a period of a few years before the papers start reporting them, and then there will be the new researchers who will point and see, oh, they actually do not copy the score number only, they do calculate it with StringBase, they do run statistical testing, and they will learn from the papers. But now we are at like the drop, so there will need to be the shift in this way.
So put differently, the whole area of deep learning has a lot to learn from us. Yes. So I think that you should try to make impact there. Like, how come that they train neural networks where every training can lead to different results, and they do not do statistical significant tests by default in their general machine learning area? That is very bad.
Yeah, I think very nice work. Matthias Müller in Zurich made a very nice working example that showed that just by changing the random seed, you can get quite strong system, different in up to one or more BLEU. And one BLEU is often considered like that's solid improvement. No, you can just change the random seed and nothing else, and you get one BLEU improvement. And that's like quite problematic. And that's something where should be at least the statistical significant testing, which also does not necessarily will result in like rejecting the model. So yes.
Okay, thanks.
Yep.
So there is a question from the chat. The first question is, what is the unit of evaluation for these metrics? BLEU is on the sentence level, but I think for some of the issues may appear on the text level, for example, anaphoras and
Yep.
such.
That's a very nice question. So in our evaluation, everything is evaluated. Well, how to put it out? We do have sentence aligned test sets. So humans have been evaluating single sentences. All the metrics been evaluating the same test set. However, for example, BLEU is calculated across the full test set. So the model, so yeah, the best answer to this question is that our models are sentence level on the sentence level, and how human evaluation also evaluates everything on the sentence level. So we cannot evaluate any cross sentence context, for example, or yeah.
Okay, and there was another question. Is there any testing being done on the usability of the translation? For example, what sorts of misunderstandings have actual empty outputs led to? Or for example, two translation may have the same score, but one gives the opposite meaning. And, you know, BERT famously is not being that good at the not negation.
Yep. That's another very excellent question. In our work, we could not evaluate this because we are using the direct assessment scoring. However, the work I cited a little bit further by Markus Freitag, where they use the MQM, multi-dimensional quality metric human framework, where they ask humans exactly tell us what are the problems, show us the words that are problematic. And they did take this into account and evaluate it. And what I remember in their paper, they did not discover any huge problems with the command. But of course, there is a lot of future works need to be done to evaluate the metrics and to see if there are problems. So what I can see is tell some like background information from Microsoft, where we are using it for like 9 months. We already discovered that Comet do not really like IT for some reason. So the IT domain is somehow just problematic. So that's one thing we discovered that's potentially problematic with the Comet.
So regarding Freitag, there's another question. In the Freitag paper that you mentioned, they report that the Comet performs the best when computing the correlation with the MQM labels. And if I understood correctly, your human scores are the DA ones, right? If so, using the DA labels plus pairwise accuracy gives very similar order of metrics as the MQM plus Pearson. Any comments on that?
Yep. Yeah, so we use the direct assessments, source-based direct assessments, and if I understood correctly, the question is that how to regarding the ranking across our evaluation and WMT metrics, Shataka's ranking of the metrics and the MQM, right? So I think it doesn't depend much on like the type of the human evaluation if it's done well, and if you have a large number of the points, then with the law of big numbers, large numbers, or how it is, it should get a similar result. So that's why I think even the WMT metrics share task already had these results in last year, a few years ago, when they've been running it. What we think with this work is that with showing it on way bigger number of systems, and basically concluding similar stuff that can be concluded from the MQM or from the past WMT works, just showing that we do have the evidence, and it's not single paper proving it. It's like a lot of the like other papers showing it as well, which should make it way more stronger that actually the pretrained metrics are better than the string-based metrics, and that character F outperforms a little bit the BLEU, and the Comet is the winning metric. I hope I answered the question, or I
hopefully.
Yeah.
Could you go to the slide with those scatter plots when you compare human evaluation and different matrices? Yeah, so I was a bit interested, like, because maybe one more, because you have like a legend there, or yeah, red points.
Yeah.
So I was kind of interested with that. Why here it seems that those red points are very centered around 0. So it seems that for translation systems that translates for language parts where we don't have English, there is not much difference, and it seems to hold both for human scores. I think even especially for human scores, and for those automatic matrices. So why is it so? Do you have some?
That's excellent question. I get this question quite frequently, and the problem is visualization only. So first the green dots being painted, then the blue dots, and then the red dots. There is 3,000 or 4,000 blue and green dots, and only like 50 red dots. So if you would put the histograms, there would be huge group of all systems in the center. There will be like majority of systems will be here, and that's why the red dots are there as well. So yeah, there are like few quite distinct systems pairs, but mainly it's just we don't have many non-English systems. That's the answer.
So red were like put there at the last, like so just on the top, yeah. So we see
so they are just pinned it on top. So if we would pin them randomly, they would probably be hidden.
Still not quite spread with deltas, so there's still, I think, quite close to 0.
Yeah. So the red dots are mainly Chinese-centric models, and we look a little bit more into this Chinese-centric models and didn't see much. And also in the later we evaluated separately Chinese, Japanese, and Korean, and there is not much difference in the ranking. So I think it's mainly the visualization. Also, from what we look into these languages in separately, we didn't see anything problems, because during the work there was a problem with BLEU, which was problem and was not actually a problem. So when I was evaluating, I ran the sucker BLEU for the BLEU, but forgot that for Chinese you have to put different tokenizer. And then all the scores for BLEU were like around like 10, 11, and super small. But actually, surprisingly, it correlates still like on the pairwise decisions. So even when the BLEU like had super low scores, it still correlated well. So then that's when I was evaluating a little bit more the Chinese-centric systems and corrected the BLEU with the correct tokenizer. And yeah.
Yeah, I thought that it maybe could be some, it's caused by evaluators, but for non-English pairs, maybe that they have a different approach, different people were evaluating it, but I don't know.
Yeah, hard to say. So we are using the same vendor to get the annotators. It will differ based on the country from where they get the annotators. We track their performance, and there are quality controls. So we do drop all the problematic annotators, and we will never give them the job again. And since they are quite well paid, so there should be the common, like they are trying to do the best work to get the next chunks. Maybe that's actually a nice point that it could be done because various cultures could have different views. So maybe the Chinese do not want to penalize the systems much and use smaller differences. Could be, I didn't do an evaluation. That's actually a very nice point. Yeah, it could be some cultural difference, for example, or the scoring. Also, it's possible that the farthest point could be some like, I don't know, Swahili or some like of our tail languages, where just the difference between the humans and between like system A and system B will be super large. Or no, that wouldn't be for Swahili. That could be maybe like when we do like a new drop of the systems, then there will be like the new system will be way better. So for example, now we are deploying huge improvements where we get like 7 to 8 BLEU points on like French. So those could be like these points which just seem to be too far. Also, the distribution is not balanced. So there is like 140 English French points and only like 15 Swahili, or like less. That was the that's like this table. So it's not a balanced evaluation. So that also have to be kept in mind, that most of the languages are like European centric.
Okay, thank you.
Yeah.
So there was just a smaller question. As for the system, how many of them are incremental improvements and how many are actually independently trained? I think that's related to the previous.
Yeah, that's a very good question. Well, yeah, there is this number, which, where was no, it was at the end. So those are just like for this type of evaluation, where we did evaluate. So we took the same sentences, translated them by other public MT and by ours. So we do run this special campaign where we are comparing with the competitors. That's why there is only like 200 systems, or some, like, not that much. I think majority of the systems in the evaluation are somehow incremental, because always the researchers are trying to beat past models, and then we deploy them, and we don't run always the comparison with the competitors. So majority of the systems will be in some way incremental. Yeah, so the question is, what would be the world without the WMT shared task? Well, I like that's super important. Like, well, the whole conference, all the shared tasks are super important to push the frontier of the MT research at all. So without the metrics evaluation, we wouldn't have that many human judgments. So we still, at this point, unless some of the companies would release their human judgment, we couldn't do, we wouldn't know that the metrics, which metrics are better. We wouldn't have the new, quite nice, every year news test sets which are coming out. So without WMT,
only incremental system comparisons and not independent comparisons. Most of the comparisons will be incremental.
No, in WMT.
If there was no WMT.
Well, if there will be.
WMT brings the independent evaluations, kind of.
Oh. So if I understand, no, in our work, it would be the same. So we would still be comparing with Google, Amazon, Yandex, DeepL, etc. So in this evaluation, we would have the independent. We would never have independence because of the news systems where the people are sending their outputs of their systems. Was the question? I'm not sure. Yeah.
From the audience, or do you have any question over there? If not, then I would like to thank, first of all, the speaker, and I would like to invite you to 2 events. I mean, the main event, of course, is our next seminar next Monday, where we'll be back to trial dependency tree bank, and there will be a talk on the new edition of the tree bank and the treatment of numerals in the new edition. So you will be most welcome. And then there is an independent event, which I think might be interesting for most of you or for us. Tomorrow afternoon from 4 o'clock in the afternoon, there is a public talk or meeting at the Scientific Society. And the talk will be, it has a nice Czech title, Krásné společenské stroje, nice social machines. And I think that the people who will be there present, I mean, the people who will have their talks or will lead the discussion are quite interesting leading personalities, both either in science or in some other respect. So the announcement is on the board with it's also online. You may come to Narudnchida, but there is also an online version of it. And here is the announcement. So if you want to look at it, it's here. But it's also on our board near the staircase. So thank you very much. Thank the speakers, thank the audience, thank those who were on the Zoom and were active in the seminar. And I'm looking forward to see you next Monday afternoon. Thank you.